Hi y'all. So today we're going to finish up Unit 6. So talk about 6.7 through 6.13. So this is a quick overview. All right. The concepts today, we're going to talk about the different renewable energies. And then also I'm going to go into the different forms of energy conservation that the AP test wants you to know. So definitely not all encompassing, but just what the AP test wants to know. All right. So to get started, we're going to talk about wind, hydroelectric, solar thermal, geothermal, wave tidal, nuclear, or we're not going to talk about nuclear, I'm sorry, we talked about that last time, but biomass and solar panels. And all of these forms involve a turbine, right? Just like in we talked about last session with the fossil fuels. And then just the solar panel does not include a turbine because it's actually driven by a chemical reaction. All right, so we'll run through these quickly. All right, so the first one I want to focus on is energy from biomass. So biomass is literally as it sounds. It is like wood or algae or whatever that can go through this combustion that's happening here. And so just a quick overview of how combustion gets turned, all of this energy from combustion gets turned into energy. And so basically it runs through this boiler, which heats up, all of this heats up the water that's in here, which then eventually all of this steam then turns this turbine. And so it's all about like, how do we get the turbine to turn, right? So yes, this contributes to climate change, as the AP test wants you to know, because it still releases carbon dioxide. But at least the fuel itself is renewable. So like the fuel, we can replenish this source during our lifetime very readily. And it is slightly more expensive than coal. So the cost up front is more, but it is renewable. Okay, so we'll talk about solar energy. There's two types of solar energy that they want you to know for the for the AP test. One of them is solar thermal. And so solar thermal, obviously the energy source is the sun. And so the sun, there's these contraptions that trap like solar heat that comes in. And so that is also there's a turbine that is being turned as this energy is funneled into water and then steam is produced. So does it contribute to climate change? The AP test wants you to say no, but also a little bit of nuance is that like the materials it takes to make this contraption and to create the device that will capture solar thermal energy definitely still takes resources. So, you know, it's not like net negative or like it's not like a neutral source, but it is definitely renewable, which takes out a lot of the carbon dioxide and other damages that happen. The cost is that it's much more expensive than coal. So you'll find that for most of the renewable energy sources, it is a higher cost up front than it is for coal, oil, and natural gas. And so oftentimes that gets used as a reason as to why we're not switching to it. Okay, the other one, like I mentioned before, the other solar energy aspect is solar panels. So solar panels, it relies on a chemical reaction that's happening. So of course, it is the sun that is the energy source. And so the chemical reactions happen. It does not, again, short answer, it does not contribute to climate change. And it is, again, much more expensive than coal. So yeah, so these are things that we've heard of. If you've driven around California, you've probably seen large solar panel fields around. All right, so because you know, renewable energy is our future, I also want to illustrate like the potentials or the opportunity for solar. And so right now, a lot of the solar energy you can see here, California is doing a great job optimizing the amount of sunny days we have, which is great. And so is like areas of the East Coast. But they're saying that scientists say that the potential for harnessing solar energy is really high in these areas. So you see here down in the south west, people are not taking advantage of harnessing solar power as much as they could. So when we're moving more towards renewable energy, the Southwest should definitely be thinking about like solar as an opportunity to take advantage of. All right. Okay, so moving on to hydroelectric energy. This one is already pretty prolific. So hydroelectric energy is just the energy harnessed by water. And so it happens in a couple of different ways, but any sort of like flowing water is a potential energy source because, you know, thanks to gravity, there is a way that we can turn that turbine via just flowing water, right? Does it contribute to climate change itself? Like, does it release CO2? Technically, no, but it does alter the ecosystem to have like a giant dam built. And so, not sure if you studied it in your other environmental studies classes, but of course, dams disrupt the ecosystem in a very large way, as you can probably imagine. And so, I want to say like a very high percentage. It was, I think, like 70 or 80% of the Western US is dammed. The water, it has a dam in the watershed. And so this hydroelectricity has taken root in the US, and it is slightly cheaper than coal. So it has costs such as disrupting the ecosystem, but like these renewable energy resources, there's no carbon emissions. All right, so then there's geothermal energy. So geothermal energy is when we harness the energy from the earth to power our electricity. So the energy source is the heat within the earth. So places where there's a lot of tectonic activity, remember when we learned in Unit 4? So places like California is a great place for it. So does it contribute to climate change? No, because we're literally tapping into like the heat within the earth, and there is just bountiful amounts of that. It is cheaper than coal, which is really cool. So essentially, and I'll show you a map. Right now, there already exists. So focusing on the green, there exists certain places, especially in California, that have started harnessing geothermal energy. And so what that means is that you can see like places where there's a lot of tectonic activity, there is heat being released from the earth. And so then building a power plant on top of those places where you're capturing that heat and then funneling that heat into a place where it can turn the turbine, and then which then generates electricity. Right. And so you can see in the green, these places in California and Nevada have started harnessing energy in that way. However, not a lot of green on this map, but they're saying that scientists have found out that like there are a lot of locations in the US that have very high geothermal activity. And so of course, you know, if you lived up here or you lived over here on the East Coast, you couldn't really harness geothermal energy that doesn't exist there. However, in like all of these spaces where it's red, there is a lot that you can potentially harness, which is dope. Okay. So one of the last ones is hydrogen fuel cells. And so this you should have seen on like buses, a lot of vehicles, like mass transit vehicles have hydrogen fuel cells, but essentially it operates like a battery almost. And so the energy source are hydrogen atoms that get separated into protons and electrons. And so it operates kind of like a battery. Does it contribute to climate change? Short answer, based on atmospheric emissions, no. However, it is more expensive than coal because it is like basically a battery. So that's hydrogen fuel cells. Now, wind energy, this is the one that maybe we're already familiar with, but essentially the energy source is wind. Shocking. So, you know, does it contribute to climate change? No. It does not release any atmospheric emissions. All right, and then it's significantly cheaper than coal. So you might be wondering, like, then if it's cheaper than coal and it like is, you know, does it have emissions and does that contribute to climate change? So these are the places where there is a lot of what they call wind farms. So like a piece of land that has a lot of like wind turbines built on there. And these are places that it's very windy in the Great Plains over here, which is great. But however, there is just like so much potential for wind farms. And so like, why have we not harnessed all of this space up here? You know, like all of this empty space here. And oftentimes like with wind farms, they're loud, they're big, they kind of people don't like them because they'll obstruct landscapes. It's just like this big tower in them, like, you know, in on the land, and some people find it not so pleasing to look at. I personally think they're beautiful and very exciting, but that is definitely like an opposition that people have to it, which is unfortunate, but it happens. Okay, so then that brings us to a separate one that the AP test isn't mandated that is required, but I have had students use it as a piece of evidence on like an FRQ. But there's wave and tidal energy, and this is pretty important in the Bay Area. So the energy source is waves in the ocean. So obviously, like with the tides, water comes in and water comes out. And so anytime there's big movements of elements like that, when water moves in such a way, there's energy that is potentially able to be harnessed. So like I said, when the waves come in and out, it turns the turbines and it moves the turbines. And so with that, of course, it does not contribute to climate change, no emissions. But it is much more expensive than coal. All right. So this brings me to energy conservation. So for energy conservation, if you take a look at this map, this is how much energy used per capita throughout the world. So capita meaning person. So in the US and Canada, you can see that people use a lot of energy per person here. Each person uses a little bit less energy in like Brazil and Mexico. Obviously, people use a lot of energy in Saudi Arabia and also Australia, Russia, yada, yada. Something to keep in mind is that this graph kind of shows the different ways in which we as the US use energy. And so a lot of it goes in electricity, a lot of it goes some transportation, residential, meaning like, you know, plugging in your refrigerator, turning on the TV, all of that. And industry is like manufacturing and whatnot. So you can see electricity takes up a huge part of it. Okay, so there's a few different ways that they want you to think about energy conservation and how we are attempting to do it as a society. One of which is personal energy use. So like in order to identify changes that will make the biggest impact, we need to know what things in our house use the most energy, right? And so this is something that they promote in AP and APES, is to like know what takes a lot of energy and what doesn't. So just to kind of give you a little overview of it. So there's air conditioning takes the most, washers take the least, and then everything in between like lighting and water heating, refrigeration, and television. And so I think the AP test wants you to be aware of like where we use electricity in our personal homes. All right. So we were talking about our personal homes. We're going to expand over to like kind of like communities and societies. So there's a concept of green buildings. And so it's like this, so there are other things that can be done to make homes and business more efficient, and using like greener materials, like improving insulation and whatnot. And so so there's a big movement in order to encourage people to construct buildings in this way. A nonprofit called the U.S. Green Building Council started a sort of awards program, and it's called LEED. So it stands for Leadership in Energy and Environmental Design. All right, so this nonprofit was like, we will award your building like LEED certified or some tier in our LEED program if you meet this, and this requirement, which makes your building like greener or like more efficient, less like using less energy. So you may have seen this this emblem on certain buildings that like, you know, maybe they have really good insulation. Maybe they like build the building in a way where like when the afternoon sunlight hits, it doesn't heat up the building really intensely or something. So like green buildings, you can see there's like a lot of different ways they can be green. So they get awarded for like innovation. So if they're doing something like really groundbreaking, indoor environmental quality, like using natural light rather than having to turn on the light. If they're recycling or like reusing, are they encouraging the people that work in the building to use local transportation and mass transit rather than like people driving in? Is there green space? Like, do they have a green roof? Do they have water catchment systems? Energy and atmosphere, so like optimizing sustainable energy production and metering. And then of course, water efficiency. So are there toilets like flushable via like gray water? All of these different things. And so, you know, all buildings kind of vary in how green they are, quote unquote. And so there's different like levels. And I think actually Ojai is in the silver level, but I'm not 100% sure because I think we installed solar panels. So technically we're silver. Okay, so buildings is one thing. Another faction that they, this has appeared in a lot of materials on the test. So one of them is gas hybrid electric cars. And so we have gas cars here like a Ford Focus or the hybrid, which is a Prius, like the Tesla, or like there's a bunch of electric cars now, but fully electric cars. And the one thing that I want you to take away from this is that the gas car obviously emits the most CO2. Hybrids less, but still some. And then the electric, almost none. And I say almost none because it still takes material to build a Tesla, right? So for electric cars, why is the CO2 isn't the CO2 zero? Because technically they're like, they don't emit CO2, right? But they still don't run on nothing. They still need electricity. So like, as long as electricity is being fueled by like coal and natural gas, it is at least partially dependent on fossil fuel. So there's some CO2 emissions. Okay, so why is it still lower than gas cars? Power plants are way more efficient than car engines. And so even if you're getting, you know, electricity from a coal or natural gas power plant, it's still a lot less CO2 than what you would put out with a gas car. And it's way easier to control emissions at a few power plants than at the engines of millions of cars. All right. So could electric cars ever be zero? Yes, they're actually building an electric car right now that is covered in solar panels, which is actually really cool. But that would be super dope. Or if all of like our power plants switched over to solar, wind and power. So that's the dream. All right, so that's it this week. So for this week, I want you to, other than watch this video, which thank you for doing, go over the AP College Board 6.7 through 6.13 videos. And then here's your chance to finish your Unit 6 progress check all the way, now that we've gone through all of Unit 6. All right, thanks for tuning in.